and welcome to today's Discovery Lab Live at the Rory Myers Children's Adventure Garden at the Dallas Arboretum. Let's welcome out today's lab specialist, Laura!
Hi guys, I hope you're ready for a really fun lab today. Today we're going to be talking about density. That's quite a word, isn't it? Density is kind of how much stuff is inside something. It's kind of a weird way to put it. But like here at the garden today, there's 3 of us here, and a raccoon that went by a little bit ago. So the garden is not very dense. But on Easter weekend, when there's a few thousand people here, we could say the garden is pretty dense. There's lots of stuff inside, lots of people in there. So we're going to look today at things with different densities. To start off with, I have a big thing of water. And I'll bet some of you have played with things with whether they sink or float. And whether they sink or float depends on the density of the item you're putting in the water. If it's more dense with water, it's going to sink. If it's less dense than water, it's going to float. So let's start off with, I have this nice big rock. Now, if I drop this rock into my thing of water, what do you think is going to happen? Let's find out. Pull my sleeve up because I don't want to drop it because I don't want to break my thing. But he definitely sinks. So we know that rock is denser than that water. But what about if I go with this little rock? Is it going to sink because it's more dense, or is it going to float because it's less dense than the water? Let's find out. Oh, went straight to the bottom. But how about if I go with this teeny tiny rock? What do you think? Well, let's try it out. And he goes straight to the bottom too, because rocks are denser than water. There's a lot more molecules in that same amount of space. But even if I take some sand on my finger here, and I put that in the water, it sinks. So it doesn't matter how big or how small something is, it has to do with its density. So looking at the opposite, if we go with this toothpick, it's made out of wood. What do you think will happen if I drop this toothpick into the water? Let's find out. Yep, he floats. Oh, so that means that toothpick that's made out of wood is less dense than the water. But how about if I go with this tree cookie? A little bigger. Do you think it's going to sink or float? Well, he floats too, because wood is less dense than water. But what if I go with this big piece of wood? Let's find out. Yep, he floats too, because wood is less dense than water. So let's look at one of the fun things to see whether it sinks or floats. Because you saw we were doing different sizes. Here I have a can of Coke and a can of Diet Coke. Now what do you think is going to happen when I drop these into the water? Let's find out. You'll notice the Diet Coke floats and the regular Coke sinks. That's because the sugar, the artificial sugar that's in the Diet Coke is less dense than the real sugar that's in the regular Coke. So because even though they're the same size and they're both 12 ounces, got the same amount of Coke in each, one sinks and one floats because of the density of the sweetener. So that's all fun, but that's just doing with water. The different liquids can have different densities as well. So what we're going to do now, after you've got your stuff ready, this is the time to look at this stuff, is we're going to talk about the density of different liquids. And here I have, let's go through them real quick. I have some honey. I have some corn syrup. I dyed mine red just for fun. If you have a regular color, that's perfectly fine. I have some dish soap. This bottle happens to be green. Sometimes we use blue. You got yellow, doesn't really matter, whatever color you got. I have some water. I dyed it blue just to have a little bit of variety. If you just go with plain water, that works well too. Some vegetable oil, it's naturally yellow. And then some rubbing alcohol, and I dyed mine purple, once again, just because I was going for the rainbow thing. If you have them regular color, your experiment's still going to work the same. So what we're going to be doing is we're going to be putting those liquids into this base in order to make what's called a density column. We're going to have the things that are the densest will go to the bottom. And then we'll go up, we'll get less and less dense. Now, today I'm using this vase. Usually when we do this here in the lab, we use this little tiny thing. You can use whatever size you have between. Just make sure you don't put too much stuff in so you don't run out of room. So I'm going to look at this and I'm going to try to do like 1/6 of a thing each time so I can fill it up nice and full. So can we get a little zoom in on my vase here and we'll get started making our density column. I'm going to start off with the honey. Okay, are we ready with the zoom-in camera? Okay, great. Now I'm going to start off with the honey. Luckily, honey comes in a squeeze bottle because I don't want the honey going down the side of the vase. I want it to stay in the middle because if it goes down the side of the vase, it's going to leave a sticky thing. Now, if a little bit gets on there, it's not the end of the world. We'll just turn that to the back. But I'm going to start off squeezing here with my honey, and I'm going to squeeze right in the middle, and this is probably going to take a while. You know what? I am going to cheat. And I'm going to take this squeeze lid off and I'm going to pour that honey down the middle because otherwise we'll be here till midnight. But I'm going to pour it. You notice I'm pouring right smack dab in the center because I want to have a nice layer of honey and I don't want it on the glass. So if you have a smaller glass, you just be a little more careful. I'm going to pour my honey in here. Okay. Now it's not all going to come out of my jar because honey is very dense and it does not like to pour very much. So I have a nice little section of honey here at the bottom of my jar. So next up, we're going to go with my corn syrup. Now, honey is the densest of the liquids that I have today. So it's going to be at the bottom. And as we go up, each of the liquids is a little less dense. So we're going to try out my corn syrup here. And I'm going to start pouring again in the middle. Honey was pretty orange, so I don't know how well you can see it yet, but there's a layer of honey at the bottom that's pretty golden, and then my corn syrup. I should have dyed my corn syrup another color today. But at the end, it'll work out right. It's kind of settling out now. You can see the line. Next up, I'm going to go with some dish soap, and I'm still going to pour in the middle. Okay. Oops, I almost got it on the side of the glass there, didn't I? Oh, that was like a nice little section of green there. So you can see my kind of golden honey, my red corn syrup, and my nice green dish soap. My column is working so far. Let's see, next up, I have some water. I dyed it blue. Now with the water, if I pour water straight into the dish soap, you might know from washing dishes, they're going to mix. So this time, I'm going to try and pour my water down the glass so it kind of slows it up. That's why the squeeze bottle is nice. If not, if you're pouring from something else, just put it right up to the edge and pour very slowly, okay? Actually, I think I'm going to do that instead of use squeeze bottle here. Okay, so I'm going to put it right up to the edge. I'm going to pour very slowly. Okay. Am I getting a layer of blue on there yet? I can't see from this angle. Okay, so now I have a nice layer of blue here. Our column's looking good. I'm going to set my blue back there. Next up, we have some vegetable oil. So I'm going to do the same thing with that. I'm going to pour it carefully right down along the edge. So I don't want my layers to mix. Now I'm going a little fast, so if you need to pause me for a minute and be not quite live, that'll work too. Whoops, I need to be going down the side a little bit. I was mixing up there, wasn't I? A little slower. There we go. We're getting a nice layer now of the vegetable oil. Be a nice yellow layer there. Okay. And last but not least, I have my isopropyl alcohol, my rubbing alcohol. And I'm going to do the same thing. I'm going to pour slowly right along the edge. You'll notice as I'm pouring, it's kind of going down, but then it's popping back up to the top because it is less dense than the vegetable oil, so it'll float on the vegetable oil. Okay, let's let that settle in there for a minute. Ooh, now we got a nice column going. We got all our layers. You'll notice we have some nice orange here at the bottom, which is our honey. Then we have the corn syrup, the dish soap, the water, the vegetable oil, and the alcohol. And you'll notice they're not mixing. They're staying in separate layers because each of them has a different density. So this is all fine and dandy to play with, but I'm curious. Remember earlier we were playing with solid things and dropping them in to see what happened. So I've gathered up some stuff that I found around here in the lab, a lot of my snacks, quite frankly, and we're going to try dropping them in here and see what happens. So to start off with, I have a big thing of staples. And I'm not going to go quite that many because my vase isn't quite that big. But here's a thing of staples. Anybody know what staples are made out of? They're made out of metal, aren't they? So do you think if I drop these staples in, do you think they're going to sink? Are they going to float? Do you think they might stop somewhere in the middle? It all depends on the density. Let's drop it in there and see what happens. Whoops, it's going straight down. Whoops, I think we caught some air. Yep, he's slowing down because that's thicker, but he's still going down. He's going down. And he's going to sink all the way to the bottom because metal is denser than any of our liquids. But now I have, let's see if I can even pick this up today, a little thing of a couple of staples. What do you think is going to happen if we put two tiny little staples in? Are they going to float, stop somewhere along the way, or sink to the bottom? Let's find out. They're still going down. He's all the way to here. He's slowing down because he doesn't weigh a whole lot, but he's still, and the liquids are getting denser and denser. He's still working his way down, and eventually it's going to find its way all the way to the bottom because it doesn't matter whether it's big or small. Remember our rocks earlier. If they have a different density, they're going to go to that level. So it's now to the bottom of the red. It's getting ready to hit the honey. Slowing down because the liquids are getting denser. So they're probably pretty close to the level of honey since it's having a hard time working it through the honey. But it depends on that. So let's see what else I have here. Let's see what happens. I have some raisins. What do you think will happen if I drop a raisin into this? You think it's going to sink, float, or stop somewhere in the middle? Let's try it out. There he goes. Okay, he's worked his way through the water. He's worked his way to the dish soap. But he's going to float on the corn syrup because raisins are very sweet, just like the corn syrup is. They're both kind of a lot the same. So they're going to stay at that same level. Let's see what else do I have in here. I have a little jewel that I found back in the back. Now, I happen to know from some of our experiments that this little jewel will float in water. So I know he's going to float in water. But above the water, we have vegetable oil and we have rubbing alcohol. Do you think he's going to stop there or is he going to stop at the water? Let's find out. Okay, where'd he go? Whoops, how did he end up going through? Oh, well, that is really bizarre because when I've tried to do experiments with him, he floated in the water and now he's made it all the way down through the water, down through the dish soap. There's a surprise for me. Sometimes experiments don't work as they're planned. Oh, let's see. Oh, I have a little pumpkin racer. Where do you suppose he's going to stop? Where didn't... Okay, now I can't even see him over there. Okay, let's drop him in. Oh, oops, he's shooting all the way down. Oh, he's going through the corn syrup. Is he going to hang out in the corn syrup or is he going to go through it? What do you think? He's down here now. Let's see. He's at the honey. Do you think he's going to sink in that honey or is he going to hang out? Huh? He's going down through the honeycomb. He's going down all the way to the bottom. So that eraser was denser than any of our liquids. Oh, let's try out. I have a sunflower seed without the shell. What do you suppose is going to happen to the sunflower seed if we drop it in? Let's find out. Okay, where'd he go? I lost track of him because he's hanging out here in the vegetable oil. You can't see him in there, but trust me, he's floating on top of that. Because vegetable oil is the same density of sunflower seeds. You might even see at the grocery store sunflower oil sold right next to that, and they have the same density. But here I have a sunflower seed that's still in the shell. What do you think will happen to that? Let's drop it in and find out. He floats up at the top. Why do you suppose that is? Well, it's because inside that shell, if you've ever eaten one out of the shell, there's a little bit of air pockets, and it's kind of working like a little life preserver and holding that up at the top. Ooh, here's something else fun I have. I have a peanut M&M and a regular M&M. I seem to have a lot of candy in here, don't I? So, what do you think? You think they're going to stop at the same place or someplace different? I've never dropped these in before, and I don't know. So let's find out. Here's my peanut M&M. Let's see where he goes. Oh, oh. Okay, so he's hanging out at corn syrup. That makes sense because if we read the ingredients on M&Ms, I'll bet that coating has a lot of corn syrup in it, the candy part of stuff. Do you suppose the regular M&M is going to go to the same place? Let's find out. Yep, cruise along there. Yep, they both stayed on top of the corn syrup because they have that same thing. And on my whole sugar thing, here I have a little gummy bear. What do you suppose is going to happen with him? Yep, he's hanging out there too. Now you might find all sorts of different little things around your house. And whether you make a little tiny density column or a big density column, just find things that'll fit in there. And you can drop them in and figure out what their density is closest to. So we know some things went all the way to the bottom, so they're denser than any of these liquids. And some things stayed at different levels. So experiment with your own stuff at home and try out and check out your density rainbow. JC's
Talk to you before it's time to go. And I'll kind of block all of you.
All right, everyone. Let's give a big round of applause for Miss Laura for helping us out with our density columns today. In case you were here last week or not, my name is JC Hood. I'm the Public Programs Manager here at the Rory Myers Children's Adventure Garden, and this is Discovery Lab Live. While the Children's Garden is closed for routine winter maintenance, we are taking the lab to your home. So make sure you tune in every Tuesday at 4 p.m. to catch the new lab. And Miss Laura,
Yes.
have you announced next week's lab yet?
No, I have not.
So next week we will be doing a mixture of solutions. So make sure on Thursday that you keep an eye out for your weekly Children's Adventure Garden email with all of your ingredients, or check on Facebook for the list of the ingredients there as well that you need to look around at home to pull together to do next week's lab at home. And hope you will join us then and continue supporting the Dallas Arboretum. Thanks, everybody, and have a great day. Bye-bye.